In this video, we're going to talk about how we actually graph all types of linear equations, even when they're not in slope-intercept form. In that last video, we showed one example of how you graph a line that's already written in slope-intercept form, which means it's solved for the y variable. So, just to practice another one, this first one, y equals negative 5x plus 3, if I wish to graph that. Very simple. Since it's already solved for y, that's big. I have my slope. I'll just write it as an m. And I have my y-intercept, right? And you can't start with your slope. You always have to start with the y-intercept because that's a location point. So, what is one point this line passes through? Well, it passes through the y-axis at, -3. So, positive 3, it's hitting the y-axis at positive 3. And the slope from there, how steep is this? Well, when you write negative 5, you have to think of that as a negative 5 over a positive 1. Or, if you prefer, it doesn't matter. You can call it a positive 5 over negative 1. Now, that's giving you two different directions to go, but it's still going to be a point on this particular line, y equals negative 5x plus 3. So, if I treat my slope as this, I'm going to go down 5. So, 1, 2, 3, 4, 5. And then to the right 1. But had I gone up 5 and left 1, you can see it doesn't matter. 2, 3, 4, up 5, left 1. It's not the same point as that, but it's still another point on the line. This is a very steep line, and you could keep counting out your slope, either going down 5, right 1, or up 5, left 1. They both represent a slope of negative 5. This is a pretty steep line. Your second line, 3x plus 2y equals negative 6. Well, here we have a problem. It is not in slope-intercept form. We need it solved for y. So my first step, I need to solve this for y. I'm going to subtract 3x from both sides. Now, of course, these don't combine. We would write this as 2y equals negative 3x minus 6. Right? And then you're one step away. Literally, you have to divide both sides by 2. Now, when I say both sides by 2, I don't think that helps us to see a giant fraction here for slope-intercept form. You're going to individually divide both of these numbers by 2. So what we get in slope-intercept form, this will be y equals negative 3/2 x minus 6 divided by, negative 6 divided by 2 is negative 3. This is our equation in slope-intercept form. And again, from there, well, here's our y-intercept. That's the first point you're going to plot. And here's our slope. Again, we have the same situation with this negative. Negative 3/2 does not mean negative 3 over negative 2. Negative 3 over negative 2 is positive 3/2. This is either negative 3 over positive 2, or it's positive 3 over negative 2. One or the other. It should not matter. So let's get rid of this first line. Right. When we plot this line, we have a y-intercept of 0, negative 3. It's the y-axis at negative 3. And then from there, we either go down 3, 1, 2, 3, right 2, or we can go up 3 and left 2. It doesn't matter. It's still going to be a point on the line. You should all literally line up. So when your equation is not written in slope-intercept form, like this one was not, you definitely need to write it in slope-intercept form. Okay? Another case in point. That's not slope-intercept form. We want to write it in slope-intercept form. So what we're going to do is we're going to solve for the y variable, get y by itself, but I suggest first we distribute that 5/3. So let me write underneath here. I'm going to run out of space. Whoops. Still have the y minus 6 equals, well, that's 5/3 x when you distribute. 5/3 times 3 is just going to be 5. Right. Then we'll add 6 to both sides, and we'll have our slope-intercept form. So y equals 5/3 x plus 11. Right. Now that's in slope-intercept form, we can see the y-intercept. I think we're okay just using this. Is up here at 0, 11. And then we count out a slope of 5/3, which means from here we go up 5, 1, 2, 3, 4, 5, and right 3. There can be a point. Now, this could be a real problem, especially when you have a grid that's only 10 by 10. And if you don't want to scale, I understand that. We did not have to go up 5, right 3. We could have gone the other direction. A positive 5/3 slope could also be considered down 5 and left 3. So I could have just as easily gone down 5 and left 3. You can see that's still going to be a point on the line. So you always have two ways you can go to locate another point on a line using your slope. Okay, this last one, y equals -4. Now this one seems to be missing some things, and yeah, what is it missing? You don't have an x variable. Now that's not a problem. It just means when you solve for y, which this already is, it's in slope-intercept form. Well, where's the x? Well, there's no x because the x got multiplied by 0. In other words, they could have written this equation as y equals 0 times x minus 4. But nobody writes 0 times anything because 0 times anything is just 0, so why even bother writing it? And they don't. So that's what you have to kind of gather from an equation like that. So with this in mind, we have a y-intercept of -4. I should get rid of these. The y-intercept is -4. And here's where people get confused. They get that the slope is 0, but they don't understand what a 0 slope means. How do you write the number 0? Well, some people think it's 0 over 0. That's not true. 0 can be represented as 0 over any number but 0. So you could put 0 over 4 if you wanted to. You could put 0 over -3. You could put 0 over 7. Any of those work as far as our slope is concerned because they're all equal to 0. So you just pick one. It doesn't matter because that's basically saying from this point, your rise is 0. Don't go up or down at all. But from that point, now you need to go right 4. Or left 3. Or right 7. It's not going to matter. You're going to be on what's known as a horizontal line. And that's what you get when you don't have an x variable. You get a horizontal line. And likewise, the same can be argued when it's a vertical line. When they go straight up and down, the problem is with a vertical line, we can't even put it in slope-intercept form. A vertical line is missing the y variable. So you might see something like the equation x equals 3. Well, I can't say what's the slope, what's the y-intercept, because we got a real problem here. The slope is actually not 0, but it's undefined, which means if you've ever seen that symbol, it means the slope is infinity. Well, that represents a vertical line. It has an infinite slope, a slope number so big that it blows up to infinity. That's what we're talking about. Now, how do you graph a line that has, this vertical? There's lots of vertical lines out there, true, but this one says x equals 3, which means your x-coordinate for all the points on this line have to be 3. So, 3, pick a number. 4. 3, pick a number. -1. 3, pick a number. 17. Whatever. The x-coordinate is 3. End of discussion. I don't care what you pick for your y-coordinate. The x-coordinate is 3. And then you'll see you do get a vertical line. So 3, 4. 3, -1. Okay, that was a little silly. 317, I guess we have enough space. There's 317. You can see they all lie on this vertical line. It's just the problem with vertical lines, we really can't put them in slope-intercept form. We can't solve for y because there is no y to begin with. Those are the real issues, and those are the special ones that we throw out when we talk about linear functions, because this one is actually the only line that is not a function. So, all right, last thing I wanted to mention on this particular video, we should be able to go backwards, and this kind of leads into the next section. If they graph a line out for you, like for example, let's say they graph this line. So this is kind of a reverse situation. Instead of, okay, graph this line for me, y equals negative 5x minus 3, they're giving you the line and they're saying, okay, write the equation of this line. This equation, or this line, has a specific equation to it. How do I know? Well, because this line has a specific y-intercept and it has a specific slope. So if we can identify those two parts, we can kind of reverse engineer an equation back this way. So what are the two parts? They're the slope and the y-intercept. Let's start with the y-intercept. Very clearly, our y-intercept is y-intercept is 0, 6. So we could just say it's 6, and that's representing our b value. So when we write our equation, it's going to be y equals some number times x plus 6. We got our y-intercept. Well, what else do we need? We need the slope. So how do I get from point A to point B, moving up or down, then left or right? The answer is we'd have to go down 1, 2, 3. Since we went down 3, that's negative 3. And then we're directly across from it. We'd have to go right 2. So what's the slope of this line? The slope of this line is negative 3 halves. So we'll say slope, rise negative 3, run 2. We'll call that negative 3 halves. We have all the pieces necessary. We write the equation. The equation would be, well, y equals mx plus b, where now we know the m was negative 3 halves. Put the x plus the b, which is the y-intercept of 6. So this is a big component of what your knowledge assessment is going to be working with as far as linear equations go. They're going to graph a line, and they're going to see if you can actually write the equation. Now, these are not so bad when they give you the y-intercept. The problem is what happens when the y-intercept is not known. Well, that requires a little bit more effort, and we'll see that in the next video.